Welcome to the fourth part of thermal properties of matter. Expansion of liquid. When a liquid is heated, its container also expands. The observed expansion of the liquid is called apparent expansion, which is different from the real expansion of the liquid. Coefficient of apparent expansion is the apparent increase in the volume per unit original volume for 1 degree Celsius rise in temperature. And the coefficient of apparent expansion of the liquid is given by gamma with subscript A that denotes the apparent expansion equals to apparent increase in volume divided by original volume into rise in temperature. Coefficient of real expansion is the real increase in volume per unit original volume for 1 degree Celsius rise in temperature. And mathematically, coefficient of real expansion is denoted by gamma with a subscript R that denotes the real expansion is equals to real increase in volume divided by original volume into rise in temperature. And this gamma R is equals to gamma A plus gamma G. Here gamma A, you know, it is the apparent expansion and gamma G is the coefficient of cubical expansion of glass. Because generally we take and we consider only the liquid, but take care that that one is the apparent, because actually when you are heating some liquid in a container and giving heat to the container, that container is also expanding. So we have to take plus gamma G also, or instead of any another material than that of glass, then you will take the cubical expansion of that material. Here is the variation of density with temperature. When a given mass of a solid or liquid is heated, its volume increases and hence density increases. If V and V dash are the volumes and rho dash are the densities of the given mass M at any temperature T and T plus delta T, then you know that V dash is equals to V into 1 plus gamma delta T. Now volume, you can replace it by mass over density because density is mass upon volume. So M upon rho dash equals to M by rho into 1 plus gamma delta T. M can be cancelled out because the mass will remain the same. So rho dash will be equals to rho into 1 plus gamma delta T inverse. Now expand it by using binomial theorem, then you will get rho dash equals to rho into 1 minus gamma delta T. Here I have neglected the high power terms of gamma delta T because the quantity will be very less. So the density of a solid or liquid decreases with the increase in temperature. Anomalous behavior of water. Water shows some exceptional behavior. When it is heated at 0 degrees Celsius, it contracts instead of expanding, and it happens till it reaches 4 degrees Celsius. The volume of the given amount of water is minimum at 4 degrees Celsius as shown in the following graphs also, and therefore its density will be maximum at this temperature. And after 4 degrees Celsius, water starts expanding. Below 4 degrees Celsius, volume increases and therefore the density decreases. This means that the water has maximum density at 4 degrees Celsius. The anomalous expansion of water has a favorable effect on aquatic life. Since the density of water is maximum at 4 degrees Celsius, water at the bottom of the lake remains at 4 degrees Celsius even if it freezes at the top surface. This allows marine animals to remain alive and move freely near the bottom. If water didn't have this property, lakes and ponds would freeze from the bottom up, which would destroy the entire aquatic animal and plant life. Example 11.2 of your NCERT problem based upon the thermal expansion topic. A blacksmith fixes iron ring on the rim of the wooden wheel of a bullock cart. The diameter of the rim and the iron ring are 5.243 meter and 5.231 meter respectively at 27 degrees Celsius. You have to find out the temperature at which the ring must be heated so as to fit the rim of the wheel. You know the coefficient of linear expansion L T2 will be equals to length at temperature T1 into 1 plus alpha 1 into change in temperature. By putting all the values, you will get the T2 equals to 218 degrees Celsius.